Welcome to another episode of Mr. Abla Physics. Today we're going to be discussing inclined planes. Now, usually all the examples that we've seen, everything that we've talked about, objects are usually moving either horizontally or vertical. But what happens when an object slides down an incline, right? What happens when an object has something like this? These types of problems are interesting because when an object is on a ramp on an incline, then we have the force of gravity that is acting on an object trying to accelerate this down the ramp, right? Now, when we try and look at these problems, then if we keep our axis the same, this is the x-axis, this is the y-axis, then the motion will happen in this direction. The motion will happen at an angle, right? This is the motion, which will be complicated to use, right? Because normal force would be acting at a different angle, right? And then it's just complicated, right? So solving problems with this inclined planes becomes a lot easier if we simply shift our axis to have our x-axis be parallel to the plane and have our y-axis be perpendicular to the plane. When we have something like this, then the only thing that is at an angle is the force of gravity, which this makes the analysis a little bit easier, because that means that we can break down our gravitational force into its vertical and horizontal components, right? So how do we break this down into its horizontal and vertical components? Well, like this, right? We have our force of gravity here, okay, downwards, and we have an angle here, which is the same as this angle right here. So that means that if we want to break this down, then this is going to have a vertical component and a horizontal component, right? Usually known as Wx and Wy. Now, Wy will be equal to mg cosine theta, and Wx will be equal to mg sine theta, okay? Now, this way, we can always include all our forces in our analysis of problems. Now, one thing to keep in mind is that the horizontal component of weight will always be parallel to the plane and will always point down the plane, right? Gravity is never gonna make it easier for an object to go uphill, right? Gravity is always gonna make it harder. So gravity will always want to bring you downhill. Normal force, right? Perpendicular to the surface, as we always know. And if there is friction, then friction will depend on whether the object is moving up the ramp or down the ramp. As we learned on a previous video, friction force acts opposite to motion. So that means that if the object is moving up the plane, friction force will act down the plane. If the object is sliding down, friction force will act up the plane, right? So we have to be very careful and read our situation very carefully so that we can put friction in the correct direction. All right, let's look at some examples. Find the force necessary to push a 20 kilogram block up a 32-degree frictionless plane with constant velocity or an acceleration of 2 meters per second up the plane. Okay, pause the video here, take a couple of minutes, and see if you can come up with an answer for this. All right, welcome back. So here we have a, right? We have a block trying to go up a 32-degree frictionless plane. So what we have is we would have something like this, where we have our plane right here, and we will have our block. We have our plane here, we would have our block. Now, the first thing we do is, of course, draw the forces acting on this plane. Okay. Now, since this block has a mass, it's going to have a weight. Since it's resting on a surface, it's going to have a normal force. And since we are applying a force to push the block up the plane, then we are applying a force to push the block up the plane, right? This is 32 degrees, and the mass of this block is 20 kilograms, and there is no friction. All right, so the first thing we're gonna do is do our free body diagram, right? We already have here, Wi, and we have here Wx, okay? All right, so I know that Wy is gonna be equal to mg cosine theta. Wx is gonna be equal to mg sine theta, okay? Which means that Wx is gonna be equal to 20 times 9.8 times sine of 32. And this is equal to 103.9. So 103.9. All right, the first question is asking us to find the force necessary to push the block with constant velocity. So by using Newton's second law, sum of the forces is going to be equal to mass times acceleration. So forces are going to be F minus Wx. This is going to be equal to mass times acceleration. F minus Wx is going to be equal to mass times acceleration. Since we're moving at constant velocity, the acceleration is 0, which means that F is going to be equal to Wx, which means that F is going to be equal to 103.9 newtons. And then question B is asking us what force is necessary to accelerate this block at 2 meters per second up the plane. So same thing, right? Newton's second law tells us that net force is going to be equal to mass times acceleration. F minus Wx is going to be equal to mass times acceleration. F minus 103.9 is going to be equal to mass 20 times acceleration 2. Which means that we need a force of 143.9 newtons to accelerate it at 2 meters per second up the plane. All right, let's look at another example. In this next example, we have a 5 kilogram block sliding down a 30-degree ramp with an acceleration of 1.5 meters per second. Okay? All right. So pause the video here, take a couple of minutes, and see if you can come up with an answer for this. All right, welcome back. So here we have our inclined plane. We have our 5 kilogram block right here. This is 30 degrees. The block is sliding down the ramp, so it is moving in this direction with an acceleration of 1.5 meters per second squared. All right. So per usual, the first thing we do is, of course, draw our forces. Here we're going to have the weight. Here we're going to have our normal force. There's no applied force or anything like that. And we have friction. Now, friction, since the block is moving down the ramp, friction force is going to be acting up the ramp in the opposite direction of motion. Which means that all I have to do now is finish up forces with our components. This is going to be Wy, and this is going to be Wx. All right, so now let's analyze this. We're going to have that our sum of the forces in y is going to be equal to 0 because our block is not moving away from the ramp, it's moving down the ramp. So vertically speaking, our forces are 0. Okay, so that means that normal force minus Wy is equal to 0. So normal force is going to be equal to Wy. Normal force is going to be equal to mg cosine theta. Normal force is going to be equal to 5 times 9.8 times cosine of 30, which means that normal force is going to be equal to 42.43. All right, so if we now analyze our forces in x, then the acceleration is happening in the x component, right? Down the plane. So since the block is moving down the plane, I'm going to have here Wx minus friction force equals to mass times acceleration. Mg sine theta minus friction force equals mass times acceleration, 5 times 9.8 times sine 30 minus friction force equals 5 times 1.5. Right? This means (24.5) minus friction force equals 7.5, which means that the friction force is going to be equal to 24.5 minus 7.5, which is 18. So friction force will be equal to 18 newtons. Now, to find the coefficient of friction, I'm going to write it out up here, sorry. I know that friction force is equal to mu times normal force, which means that the coefficient is going to be equal to friction force divided by normal force, which is 18 divided by 42.43, which is equal to 0.42. No units, so that will be that. And there we go. Okay. All right. Hopefully these examples made sense, and thank you all for watching. See you next time.